Introduction of On Building a Theater. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. On Building a Theater by Irving Pichel. Introduction. Architectural ineptitudes are more likely to be perpetuated and in time condoned than those in any other art. Generally speaking, a bad painting is scrapped, poor music remains unpublished and unplayed, along with much good music, no doubt, and bad books after a time cease to be read. But a building is somehow inescapable. Having a durability that needs no treasuring and being erected more often for use than for beauty, a building generally achieves longevity and the bad art crumbles no sooner than the good stone. Usefulness, great initial cost, sturdy stuff are all against a building's being put out of the way merely because it is ugly, or even, as a matter of fact, because it does not successfully serve the purpose for which it was erected. As people live in a house or work day after day in a store or factory or public building, they become used to inconveniences, bad arrangement, and lack of proper facilities. They complain for a time, perhaps, and then forget. And after a while, when the house has become home or the large building has gathered tradition, a sort of admiration settles upon it. What is really plain ugly or wrong or bad appears quaint and full of atmosphere and is imitated. Style and tradition embalm the very features that make the building a bad building. In the theater, this perpetuation of musty, tradition-hallowed faults of construction has been carried to an extraordinary extreme. There is more ritual, one might believe, in constructing a stage and auditorium in accordance with honored custom than there is in the building of a church. In the more modern theaters, there have been notable improvements over the theaters of a generation ago, but in the auditoriums and stages of schools, clubs, and societies, and in other public or semi-public buildings in which such facilities are included as a sort of side issue, the ancient law is observed. The average high school stage seems to be inspired by the faint recollection of a visit to the theater, supplemented by the examination of old prints illustrating the stage of Inigo Jones. Today, by a concerted movement throughout the country, hundreds of community houses are being planned as war memorials. These buildings are designed to include facilities for all the social and recreational interests of the communities they will serve. Practically all of them will include stages and auditoriums. At the same time, hundreds of new school buildings are being planned, and these, too, will have stages intended to be useful for dramatic productions. But unless architects have at their disposal much more technical knowledge of the producer's requirements than in the past, it is certain that most of these auditoriums and stages will be bad, as are the auditoriums and stages in most existing schools. It is to forestall some of the common mistakes that this paper has been prepared, to describe them in detail and to set up against them the ideal features toward which the designers of such structures should strive. I believe that the memorial halls are destined to play so large a part in community life that they must have removed from them every obstacle to their fullest usefulness. In every community of moderate size and culture, there is a releasing today of dramatic impulse, and folks turn more and more toward the theater as a mode of group expression. The Little Theater movement, with its 85 or more centers renewing their life now that the war is over, is an evidence of the birth of a new theater in this country. Innumerable community pageants and masks are an indication that people turn to drama as a means of expressing their corporate aesthetic. The production of worthy plays by schools and colleges, the interest such institutions are showing in the writing of plays, and in the fostering of an indigenous drama, the widespread discussion of the drama and the theater by clubs, reading circles, and drama leagues, are all portents of a theater that shall be a vital and integral part of our daily community life. And at the very moment these words are being written, the commercial theater that has so long held the arena is being convulsed by a revolution that may mean nothing short of its eventual extinction. The system of wholesale manufacture and distribution of theater products is on the wane, and the theater as an art, as a social institution of the rank and significance of the school or the church, may soon have the field to itself. Hourly in the little theaters, in community drama undertakings, in the municipal theaters, in the classrooms and the clubs, and on the school stages, the new theater is growing up. One of the finest services that the Memorial Community House can render is to provide a home for the dramatic impulse of the community. Not a makeshift home, but one worthy of the fine art of the drama and the fine craft of the theater. It does not matter whether or not the building is to be large and pretentious or small and inexpensive, but it matters that it should be fitted to the least detail to fulfill its function efficiently and beautifully. I do not write these pages as an architect or as an instructor of architects, but as one knowing fairly well the conditions which a stage has to meet when it is used for dramatic representations of any sort. In the course of a rather varied experience in the theater, amateur and professional, little and big, commercial and art, I have encountered practically all the mistakes that are made in stage construction. I have found them to be of two sorts: mistakes of imitation and mistakes of ingenuity. The first type of mistake is easy enough to account for. Usually the auditoriums and stages of schools have been intended primarily for use as chapels or assembly halls. There has been a feeling on the part of school authorities that the dramatic instinct is in some way unwholesome and that its expression should be discouraged. As often as not, the design of the school stage has been a conspiracy to thwart its growth. The attitude of the authorities has recently changed somewhat, but with the change has come very little more intelligence in the matter. Where before they were careful to obstruct, they are now merely negligent, leaving the architect to his own devices. The proceeding is very much at random, and experts are rarely consulted. It is not wholly the architect's fault that he builds as he does. Opportunities to build stages are not frequent. He knows more about building them than using them, and the models he follows have not been often enough refreshed by the innovations of theater experts. His patterns are largely outmoded. In the largest high school in one of the greatest Midwestern cities, I have seen a stage built no more than 5 years ago in which is exemplified almost every stage feature of the Civil War period. A vast, curved apron, grooves for wings, and a stage floor sloping from the back wall toward the footlights. In addition, there are one or two mistakes peculiar to high schools, notably the omission of an entrance to the stage, save on one side. The other type of error which one encounters is usually made by a clever man who has observed the more modern practices in building large theaters and attempts to adapt them to a space utterly inadequate or wrongly shaped for the purpose. Usually, he cramps his space hopelessly and renders it even less useful for its purpose than it might have been had no such ingenuity been displayed. The finely equipped stage of the Artists' Guild Theater in St. Louis is an admirable replica in little of a fully equipped stage of the commercial theater. But the stage house is so small that the fly gallery at the left and the paint bridge at the back are a constant embarrassment. The stage would have been more workable if these devices had not been employed. These errors of construction, after all, indicate but one thing: that the stage has been regarded as a characteristic type of structure to be built according to established rules, rather than as a place designed to fulfill a peculiar function. A stage is a space on which a dramatic action is to be revealed before an audience. Whatever the space at the builder's disposal, its size or shape, or whatever the building he must remodel, that is the only thing to be considered. A play is to be given. The players must be seen and heard. There must be means for them to enter the presence of the audience and exit. The space on which they appear must be illuminated. Somehow the space set aside for the player shall be able to suggest, either by means of scenery as it is commonly understood, or by some conventional arrangement, permanent or variable, a world in which the character he portrays might move. Beginning with this much specification and no more, I propose to work out with some definiteness the principles underlying the construction of an ideal stage and the relation of the auditorium to it, bearing in mind all the while the fact that many of the stages in the war memorial buildings and little theaters are to be small, that large sums cannot always be spent on them, and that they must in most cases serve a variety of purposes. If we remember always the function of our stage is to fulfill, we have two good sources from which to draw practical details for its construction, and a third source, debatable but interesting. First, there are the errors which I have referred to. Some of these I shall discuss in detail in the next chapter. Then, most valuable of all sources are the conclusions to be drawn from the practice of the most skilled architects and artists of the theater. And finally, to be considered briefly, there are speculations as to the demands which the drama of the future may make on the theater, demands that can be forecasted inaccurately at best, but deserving a glance perhaps, if only to call attention to the certainty that such demands will be made. End of Introduction. Section 1 of On Building a Theater by Irving Pichel. This LibriVox recording is in the public domain. Architectural Tradition in the Theater. The Auditorium. Part 1. There are, of course, other types of auditorium and platform than that of the theater. Churches, lecture halls, and the chambers of legislative assemblies are planned with the same general end of making a person or persons at one part of the room audible and visible to many persons gathered in another part. The ready defense of much bad planning in school auditoriums is that they were not modeled after theaters, but after one of these other forms. Today, this will not serve as a defense. Interest in the drama is too widespread, and recognition of the social potency of the theater is too general. And whereas none of these other forms of audience chamber meet the needs of the theater, a well-planned theater can serve any use to which a gathered community may care to put it. The rocks which threaten disaster to our intent to devise a room which may serve as theater, assembly hall, chapel, or whatever, are, if we go to beginnings, the traditional form of the theater and its traditional decor. In the latter, time has wrought many changes. It was once felt that a theater was not a theater if it was not adorned with a wealth of gilded cupids, masks, tambours, and daggers, surrounded by stucco wreaths and garlands in high relief, and interspaced with pictured panels of the muses, especially those most at home in a playhouse. And indeed, about those old houses, their garishness now mellowed, there is a glamour peculiarly of the theater, and a sweet mustiness in the air, bespeaking audiences of perfumed ladies, long since dead, the grease paint and pomade of a long line of players, old scenery, the fine fustian of old plays. It is somewhat like the odor in a garret stored with the treasures of our grandparents, or the mustiness of an old book. But these are faded flowers that cannot be brought to life, and the theater of today, its plays and its players, are moved by a different spirit. Whatever lure these tinselly old temples have is a reminiscent one. Today, there may be found theaters with the simplicity and peace of a church, the unobtrusive luxury of the drawing room, and even, by overshooting the mark of simplicity, the bareness of the lecture room or the legislative chamber. The greater sincerity that has come into the theater and that fear of romance that marks the first decade or more of the 20th century did much to overcome traditional over-elaboration. There has come, too, a marked freedom from tradition in the planning of the usual large show houses. The more modern theaters are, for the most part, free from those glaring structural ineptitudes that several centuries of custom had imposed. In Germany especially, the traditional form of theater did not develop there. Great progress has been made, and the theaters of such architects as Max Littmann and Oskar Kaufmann serve as models. Stage machinery in Germany has been brought to a point of perfection not yet reached in any other country. Lautenschlager, Brandt, and Fortuny, a Spaniard, have contributed inventions that have only occasionally been experimented with in this country, and then somewhat half-heartedly. Tradition clings close to its native heath, nevertheless, and in England, to which America looks first, perhaps, and in the Latin countries, it has enough vitality still to be a source of danger. It may be worthwhile to scan the history of the tradition, especially from the front of the house, before we consider the stage itself, for it is from here that the gravest criticism against a stage can be made, that it is not easily visible from all parts of the house. The form of the stage and the manner in which it has been used have, throughout the history of the theater, been the primary factors in determining the shape of the auditorium. The Greek theater was devoted to a ceremonial drama in honor of Dionysus, acted about an altar erected to him. So the stage took the form of a circular space with an altar in the center. The seating was arranged in concentric tiers, with the altar as a center, and more than half surrounded the stage space or orchestra. Tangent to this circle and perpendicular to a line drawn through the center of the seating space was built the skene or back scene. At first, this was merely a dressing tent. Later, it was a wall of wood or stone, masking the dressing rooms of the actors. It was pierced with doors, giving access to the stage before it, and served as the palace, temple, or city wall, in front of which the scene of the play was laid. There is no satisfactory evidence that it gave onto a raised space conforming to the later stage platform. Chorus and actors were on the ground level of the orchestra. All the seats being raised, the spectator looked down upon the action of the play, and all the seats were set on radial lines drawn from the altar or center of the orchestra. In the Roman theater, a number of radical changes are to be noted. The large orchestra is no longer needed for a chorus, and the space is cut into a semicircle, in which are placed the chairs of the senators. Since spectators are now on the ground level, the actors must be raised, and the stage becomes a long, shallow platform, beginning at the diameter of the circle. Raised tiers of seats, as in the Greek theater, surround the semicircular ground space. At the back of the stage is a wall, or scaena, which also closes in each side of the stage, meeting the seats at the diameter ends. It is built to the height of the uppermost tier of seats. Since the stage extended almost the whole width of the seating and was raised above the ground, sight lines were ideal. Between the fall of the Roman Empire and the revival of classic learning in Italy, the theater had no settled home. The drama went through various vicissitudes, took on new functions, expressed itself in new forms. The medieval theater of mysteries and miracles, after it had become secularized, went forth from the chancel of the church and became a vagrant and an opportunist. It set up its paraphernalia in the public square, in the inn-yard, in the guild hall. For the most part, it was a daylight, outdoor recreation, with no fixed home and no such special ceremonial functions as in the Greek and Roman state. It was proletarian, distinctly. With the Renaissance, in addition to the popular itinerant theater of the people, there were two new manifestations. The humanists, in their academies, revived the Roman comedies of Plautus and Terence. The courts of the ruling families of the free cities became the scenes of magnificent productions of masks, pageants, triumphs, and fetes. These were usually allegories based on classical mythology or on ancient history, but presented largely in the form and manner of the popular drama of the time. To the presentation of the court fetes, the greatest artists, Bramante, Leonardo da Vinci, Giulio Romano, etc., brought their talents. They were given in the gardens of the palaces at night, illuminated by flares and fireworks. The pageant or wheeled stage of the medieval popular drama was used for the display of some large piece of decoration or machinery. As early as 1491, however, at Perugia, the first indoor performances were given. The stage went through various modifications, still keeping its resemblance to the stage of the medieval drama, until one invention enforced the most radical development that had yet taken place: perspective scenery. Hammett traces the invention of scenery in painted perspective to Bramante's decoration of the sacristy of the Church of San Satiro in Milan. The wall painting represents in perspective an extended vista of the sacristy in an attempt to make it appear larger. The modern counterpart is the mirrored restaurant. It is certain, at all events, that Peruzzi employed such scenery in dramatic representations in Rome before 1510. With these painted prospects came a variety of changes in the arrangements of the rooms in which the masks were given. The stage became more a place apart. It was set at the end of the room rather than along the sides, that the effect of distance produced by the painted prospects might be enhanced, and the proscenium frame enclosed it. However, when the theater as a building designed specifically for the presentation of plays came into being, the form of auditorium was not so thoughtfully adapted to this new type of stage as had been the case with the ancient theaters. For it was to them that architects turned for models for the auditorium, though the stage was no longer the stage that went with the amphitheater form of seating. The theater at the Academy of Olympians at Vicenza, begun in 1580 by the architect Palladio and completed in 1584 by his son Silo, is practically a Roman theater roofed over and equipped with a stage that compromises with the stage then in mode. It has a sloping floor to increase the effect of the perspective and alleys of scenery giving off each entranceway in the stage wall. The Teatro Farnese in Parma, completed in 1619 by Aleotti, is the first modern theater. In it appear theater features that have come down to our own day: the elongation of the amphitheater auditorium into the horseshoe form, and a stage completely separated from the auditorium and equipped not only to handle the new scenery, but to manipulate it quickly so that changes of scene might be effected in the presence of the audience. In this theater, Aleotti not only broke away from the classic stage, but also from the multiple setting of the medieval stage, and definitely introduced the modern form of picture stage. Less completely did he break away from the classic seating, but he modified it somewhat to meet new conditions. With Aleotti passed the period of primitive experiment with a new instrument. From his day until very recent years, there was to be no marked change except the introduction of balconies, a feature already anticipated in the theaters of other countries and soon employed in Italy, and the further accentuation of the horseshoe form. The old circle plan became an ellipse, and still later, as the side balconies were brought in closer to the stage, an oval. In England, very much the same history was enacted. The Old English miracle and mystery gave the theater its platform stage, but the imitations of Latin comedy first gave it a permanent home. Public performances of university-made imitations of Roman comedy were common during the reign of Edward VI and during the reign of Elizabeth, 1558 to 1603. 17 professional theaters were licensed for the exhibition of contemporary plays. In something like 60 years, the English drama and the English theater had grown from crude beginnings to the highest point they have yet reached, and it was by professional companies of actors presenting dramas and not by the court or academic presentations that the theater was first given form. These companies, like the craftsman bands of miracle and mystery players, acted wherever they could find a place, or wherever they were bidden, at court, in great halls, in the provinces, in the church, or the moot hall, or the inn, and in London, in the inn-yard, or bear pit. It was the inn-yard that was most used and had the greatest influence on the form of the playhouse. The inns were usually built in the form of a hollow square. A small passage gave access to the inner court, which was surrounded by galleries. The stage would be erected at the end of the court opposite the entrance, and spectators stood on the level ground of the yard or found seats in the galleries. The bear pits or bull rings were usually circular buildings with several galleries similar to those of the inn-yards. The earliest theaters, built about 1576, were round in shape with these characteristic galleries. They seem to have been used interchangeably for theatrical performances and for bear baiting. The centers were open to the sky, like the inn-yards, and only the galleries and part of the stage were roofed. The stages projected into the center and could be viewed both by spectators on the ground and by those in the galleries from three sides. The only contemporary drawing of the Elizabethan stage is that of Johannes de Witt of the University of Utrecht, who visited London in 1596. His drawing of the Swan Theatre differs in many details from the specifications of the contract, but it gives a general idea of the form of auditorium and stage. With the building of these theatres, the Theatre, the Curtain, the Hope, the Globe, Blackfriars, the Swan, the use of the inn-yards did not cease, and the Queen's men performed regularly at the Boar's Head in Eastcheap as late as 1603. Contemporaneously, there were in England, as abroad, spectacular performances at court, richly costumed and decorated. They were performed in spacious palace halls, being acted on pageant wagons or on the main floor, and were viewed from benches and balconies around the sides. Eventually, the pageant gave way to a stage temporarily erected at one end of the room. The dancers descended to the main floor for large ensembles and ballets. As early as 1607, scenery, curtains, and a proscenium arch had been used. The picture stage, with its scenery in painted perspective, was an importation from Italy, following a visit there of Inigo Jones, and under his hand reached a high degree of development during the third decade of the 17th century. End of Section 1. Section 2 of On Building a Theater by Irving Pichel. This LibriVox recording is in the public domain. Architectural Tradition in the Theater. The Auditorium. Part 2. With the reopening of the theaters after the Restoration, the practice of the Italian theater and opera house superseded the Old English tradition practically altogether, the only noteworthy remnant being the social distinction that made the ground level, or pit, the place of the proletariat in the theater. The visits of the aristocracy to the theater during the Elizabethan period, even when theaters were under court patronage, were something in the nature of an escapade. The sheltered galleries were reserved for the gentry, and the unroofed ground space or pit was open to the crowd. From the galleries, moreover, a better view of the protruding three-sided stage was to be had. In the later, wholly roofed theaters, the stage still protruded somewhat. A great curved apron projected beyond the proscenium. Nor was the proscenium the mere picture frame of today, but a deep portal. The balconies extended over the stage to the curtain, so that spectators at the forward ends of the balconies were directly above the stage. The balconies were given swelling curves, bringing them further toward the center of the stage, so that those who occupied these forward seats could not only see, but could be seen. The stage boxes of today are a relic of this type of apron stage theater, and today, with the picture frame stage, serve no purpose but the stupid social one of self-display. The apron stage preserved one great advantage of the platform stage, that of keeping the stage grouping for at least a part of the audience plastic, and the dimness of candle or oil footlights compelled the actors to keep to the front of the stage as much as possible. The disappearance of the apron has been due wholly to the improved lighting of the modern theater. With its disappearance should go the auditorium features that belonged with it. And even though there have been occasional reversions to the platform stage and apron in the productions of Granville Barker or Jacques Coupeau, there is no occasion for the revival of the horseshoe balcony or the stage box. In later pages of this paper, where I deal specifically with the stage, I shall recommend provision being made for an apron, either permanent or movable, but the auditorium should not revert. With modern resources in lighting and construction engineering, most of the practical considerations that determined the form of the old houses do not apply, and the social considerations that called for the display of certain parts of the audience are not even tacitly acknowledged in the more democratic theater of today, except at the opera. Accordingly, the procedure of the architect should be governed wholly by considerations of utility. The first consideration is that of visibility. A sightline drawn from any seat in the auditorium should give a clear view of the entire stage. As a general rule, therefore, the seating space should be very little wider than the stage opening. A sightline drawn from a seat to the right or left of the proscenium arch past the corresponding side of the arch will cut off that corner of the stage. The closer the seat is to the stage, the greater is the part of the stage concealed. Accordingly, it is the custom in most modern theaters to narrow the auditorium as it approaches the stage, so that the front of the seating is no greater in width than the width of the proscenium. The rear of the auditorium is slightly wider. As a concession to this plan, the back of a stage setting is often narrower than the front. That is, in the case of an interior setting, the side walls of the room represented, instead of being set at right angles to the back wall, as is the case in most rooms, are set at an angle corresponding to the sight lines drawn from the extreme right and left ends of the last row of seats. This is purely a convention required by the shape of the playhouse and pardonable on the ground that it is less irritating to look at a distorted room than to be unable to see its corners. At all events, this form of auditorium affords a higher visibility than did the old horseshoe shape. The most noteworthy move toward the adoption of this type of seating was made by Richard Wagner in the construction of the Opera House at Bayreuth. Here, the auditorium is in the shape of a fan or blunt-nosed wedge, with the stage at the narrow end. The most approved type of modern auditorium follows this form to some extent. In such theaters as the Künstler Theater in Munich, Littmann, or his Prinz-Regenten Opera House, this plan is developed. The general plan of the best modern American theaters is rectangular, with the side walls converging toward the stage, beginning at a point about 2/3 of the way from the back. The seats are in concentric rows, following a curve drawn from a center approximately at the middle of the back wall of the stage. The back wall of the auditorium follows the curve of the seats. The Little Theater in New York is built on this plan. Where balconies are included, they have only a slight curve, approximately the same as that of the orchestra seats. It is a common fault of school auditoriums that the seating is extended to the right and the left of the stage, so that a considerable number of seats are valueless for seeing. They preserve, also for no known reason other than it has been the theater practice, the apron projecting far beyond the line of the proscenium arch. The second requirement for assuring direct sight lines from every seat to the stage is an inclined floor. In many cases, this appears an insuperable difficulty. Auditoriums, which must be used as gymnasiums or dance halls, require level floors. Often, then, the stage is elevated at a greater height from the floor than usual, in the belief that this device will overcome the lack of an inclined floor. On the contrary, it merely makes the spectator tilt his head at an uncomfortable angle, makes the players appear preternaturally tall, and, as they move toward the back of the stage, conceals the lower part of their bodies. The best height for a stage, whether with inclined or flat auditorium, is 3 feet 9 inches. A number of means may be used to provide an inclined floor when performances are to be given in a hall which must be used for many purposes. In Copley Hall, Boston, movable risers were installed, each row of seats being lifted about 6 inches above the row in front. This scheme has the advantage of being the least costly at the beginning, but this consideration is outweighed by a host of disadvantages. The trestles and platforms occupy a large storage space when not in use. They are not 100% safe, and they emit a squeak with every footstep. Moreover, they increase, to some degree, the fire hazard. Far more ingenious and needing no storage space is the device employed by Lawrence Ewald in building the Little Theater of the Artists Guild, St. Louis. The theater occupies a wing of the building ordinarily used as an art gallery and has a level floor. When performances are to be given, the theater seats are bolted to the floor, and the back half of the floor, which is built in one piece, hinged at the middle of the auditorium, is lifted at the rear by a 4-ton hydraulic jack until a pitch of about 1 inch per foot is obtained. Mr. Ewald has provided me with the following account of the construction of the floor. The movable part of the floor consists of a floor-bearing structure of steel, which extends from a hinge halfway between the back of the house and the stage, and parallel with the front of the stage to the back of the house. This structure is made up of 4 I-beams at right angles to the front of the stage, and another I-beam attached to them at right angles at the back end of the house. In the cellar, immediately beneath this crossbeam, is placed an ordinary 4-ton hydraulic jack, which, when operated, revolves the back floor structure on the hinges at the middle of the house. When the floor has been raised 30 inches, 4 legs suspended from the 4 I-beams drop of their own weight into position and support the load, and the jack is removed. Had it not been for the structure of the room under the auditorium, Mr. Ewald would have constructed the entire floor on a steel frame, as described above, and balanced it on an axle at the center, where the hinges now are. With suitable space under the front half of the floor, it could have been tipped on its axle, depressing the front and elevating the back, giving an incline to the entire auditorium. Built thus, the floor would require no jack and would be amply supported at 3 points, or, with the understructure built in the form of a truss, the floor could be made to rock on the apex of the truss. With this arrangement, the front half of the floor would have support along its entire length. Another device proposed for a great municipal auditorium in a western city will not so readily commend itself for general use because of the great initial cost and because of the depth of cellarage required under the auditorium. Here, the entire floor was to make a semi-revolution. On one side of the revolving plane was a smooth flooring. On the other side, seats were bolted. When the building was to be used as a theater, the side with the seats was turned uppermost and held at the proper pitch. When the hall was to be used for a ball or for a dog show or any function needing a level floor, the smooth side was turned up and secured at the horizontal position. When the floor can be built with a permanent slope, either a simple incline or an incline in the form of a parabolic curve is used. the latter form is preferable. In many places, the fire laws limit the pitch of the floor to 1 inch per foot. With rows of seats spaced at the legal minimum of 32 inches, this does not give enough clearance for the people in each row to see over the heads of those in the row in front. For a decent degree of comfort, a little seating capacity should be sacrificed and the rows spaced 36 inches apart. If possible, there should be a gradient of 2 inches to the foot, giving a difference of elevation between rows of 6 inches. If the law prevents the 2-inch grade, the same effect can be produced by staggering the seats. That is, the seats of alternate rows are set in direct alignment, while the intermediate rows are set a half a seat width to the right or left. Thus, spectators will look between the shoulders of those immediately in front of them, and will be able to see over the heads of those in the second row in front, who, by such an arrangement, will be sitting in a direct line with them. There will thus be a 6-inch difference between each 2 rows of seats. Beyond all these considerations of adequate sightlines, however, there is another requirement far more important, far less well understood, even in the light of any guiding or misguiding tradition by the average architect. That is the requirement of good acoustics. Until quite recently, this was left wholly to accident. Buildings were erected and the acoustic properties were tested afterwards. If they chanced to be good, the owners were to be congratulated. If they were bad, great sums were spent stringing piano wires or nets of raw silk or padding the walls, and then, quite often as not, the acoustics remained bad. The late Wallace Sabine, however, demonstrated that it was possible to predict the acoustic properties of a proposed structure with scientific accuracy and to forestall defects by structural modification. In The American Architect, December 31, 1913, Professor Sabine describes the experiments by which the cause of the acoustic difficulties in the new theater, now the Century, in New York were discovered and overcome, and the methods which he employed in helping plan a number of the theaters designed by C.H. Blackhall, perhaps the most experienced theater architect in the United States. This paper and others by Professor Sabine should be read by any architect who contemplates building an auditorium of any sort. The matter is too vital to be left to a hit or miss chance of success. With an auditorium from every part of which the stage can be seen, from every seat of which all the words of the actors can be heard, there will be little fault to be found. Its comfort, its ventilation, its isolation from street noises, its protection against fire, these are matters which need not be treated here, and which have been written of elsewhere more adequately than I could write of them. As for its decoration, there are no rules to govern that. If the designer has bad taste, there is no help for it, except to avoid him. If he is an artist, let him exercise his art on the interior of the auditorium and forget the sort of thing that has traditionally adorned theaters and wedding cakes. But most of all, let him talk with the artist, if there should luckily be one, who is going to work in the particular theater, and learn from him the sorts of play that are to be done, and the aesthetic of the group that is to present them, if it has one, and so find some clue to the atmosphere the auditorium should evoke. From then on, his task is one of high creation. End of Section 2. Section 3 of On Building a Theater by Irving Pichel. This LibriVox recording is in the public domain. The stage plan. We are accustomed to regard as the stage of a theater that part on which the actors appear, immediately behind the footlights, bounded right and left by the proscenium arch. As a matter of fact, this is a very small part of the stage. From the construction of many school stages and many of the stages of the little and experimental theaters, I am convinced that this misconception really exists. It is true that many little theater groups have been obliged to choose between a cramped stage and no stage at all. On the whole, the work they have done in the light of their limited equipment is nothing short of amazing. One well-known little theater director has declared to me that he values these inadequacies because of the ingenuity required to overcome them, and I imagine that very frequently admiration for this sort of ingenuity passes current for the evaluation on its own merits of work done in these theaters. No director could be hindered, however, by having excellent facilities at his command. His imagination, instead of visioning means of overcoming too low a roof to his stage or the lack of off-stage space, would be free to interpret the matter of the play itself. It would be a great pity to lose the work of many earnest groups who have been presenting plays in remodeled dwellings, saloons, or stables with what appear to be hopelessly inadequate stages. But if a building is to be erected for the purpose of housing a theater, it will mean greater freedom for the artists, in fact or intent, who are to occupy it, if they are given every facility that foresight can provide. The stage, properly speaking, is about 5 times as large as the part of it that is visible to the audience when the curtain is raised. The spaces to right and left of the proscenium arch should equal the center space within the proscenium. Then there is the space above the stage, the space under the stage, and the space required adjacent to the stage for dressing rooms, shops, etc. Dimensions for practically all of these spaces can best be derived from the dimensions of the proscenium arch. The width of the opening generally is equal to half the width of the auditorium at its widest part. It may be somewhat less or somewhat greater, but it is well to establish a minimum of 24 feet for the width of the opening. Less than this will not give adequate space without serious crowding for the presentation of scenes with more than a very few people. In height, the proscenium should be fittingly proportioned to the width, with a minimum of about 12 feet in mind. A stage too low and too narrow will throw the human figure out of proportion to his surroundings on the stage. Let us assume that we have a stage with a proscenium opening 24 feet wide and not less than 12 feet high. The aggregate off-stage space, right and left, should then equal about 24 feet, making the total width of the stage house 48 feet. The depth of the stage should be not less than 24 feet. The height of the stage from floor to rigging loft should be not less than 36 feet. The cellar under the stage should be not less than 10 or 12 feet deep. This is merely a rough guide using the measurements of the proscenium as an index. Claude B. Hagen, construction engineer of the Century Theater in New York, suggests a rule of 7 for the derivation of these dimensions, making all of them multiples of 7. The following table gives his measurements for stages of various sizes. Proscenium width, 28 feet. Proscenium height, 7 feet less than width. Height of loft, 56 feet. Height of fly gallery floor, 28 feet. Width of stage, 42 feet. Depth of stage, 21 feet. Cellar, 14 feet. Distance between border lights, 7 feet from center to center. Proscenium width, 35 feet. Proscenium height, 7 feet less than width. Height of loft, 63 feet. Height of fly gallery floor, 35 feet, 7 feet back of proscenium. Width of stage, 56 feet. Depth of stage, 28 feet. Cellar, 21 feet. Distance between border lights, 7 feet from center to center. Proscenium width, 42 feet. Proscenium height, 7 feet less than width. Height of loft, 70 feet to 84 feet. Height of fly gallery floor, 35 feet, 7 feet back of proscenium. Width of stage, 70 feet. Depth of stage, 35 feet to 42 feet. Distance between border lights, 7 feet from center to center. These measurements, while customary, are hardly ideal and are generalizations from the more or less arbitrary dimensions imposed by high land values. It goes without saying that however small a theater is, its stage should be as large as the plot on which the building stands will allow. The off-stage space at the sides is particularly important. Without it, entrances to the scene are cramped. There is no place to pack furniture and scenery for other acts than the one in progress on the stage, and there is no place for the actors to await their entrances. Such space is needed, often, for the suggestion of other rooms than the one before the audience, and an important part of the lighting of the scene is done from the sides. Next in importance is the space above the stage, the flies, in the technical vocabulary of the theater. In this space, above the line of vision of the spectator, much scenery is hung until needed. Lighting units are suspended, and with good overhead space, effects of height can be produced and ampler places revealed than that in which the audience sits. The cellar under the stage is of especial importance, where the off-stage spaces at the sides are cramped. It is used for the storage of scenery and furniture, for stage machinery, and for entrances from a lower floor, with the aid of traps, and it often provides passage from one side of the stage to the other during the progress of a scene that occupies the entire depth of the stage. In some theaters, a part of the stage floor may be lowered by an elevator and properties or furniture disposed of during the changes of scene, thus preventing crowding of the stage house itself. Hardwood should never be used for the stage floor. The architect of the excellent Arts and Crafts Theater in Detroit, in his desire to use only the best of building materials, specified a stage floor of maple. As a consequence, it is almost impossible to support scenery by the use of stage braces screwed to the floor with a stage screw or peg. Softwood into which the pegs bite easily is the only sort to use. It is particularly important in small theaters that the stage walls be as unbroken by entrances as possible. At least 2 there must be: a large high door opening to an alley or street by which scenery may be brought in and taken out, and a small one, a stage entrance for the people of the theater. It is well so to contrive the building that this one door gives access to the stage from the dressing room corridors, shops, cellar, stairs, street, and front of house. With many doors opening on the stage, it is difficult to find space for the stacking of scenery without blocking them. It is often desirable to have one dressing room very near the stage or opening immediately upon it, not for the use of the star, but for the player who may happen to have the quickest change of costume. Stages intended for the housing of large productions and traveling companies should include also a fly gallery built out from one of the side walls of the stage at a height of not less than 20 feet from the floor. The ropes by which drop curtains, ceilings, and frame pieces of scenery are raised and lowered are operated from this floor and are tied off to pins fastened in the gallery railing, technically known as the pin rail. In smaller stages of no great height, it will save space, construction costs, and operating expense to have the pin rail at the floor level. Before discussing the equipment of the stage in detail, I wish to digress for a moment and consider the provisions to be made for the work that is done out of sight of the audience by the carpenters and property men, the seamstresses, the electricians, and the actors before they appear before the footlights. End of section 3. Section 4 of On Building a Theater by Irving Pichel. This LibriVox recording is in the public domain. Provision for backstage workers. I have noted in an earlier chapter that the architecture of the theater is always governed by the function of the drama performed in it. The use to which the stage is put determines always the shape and style of the auditorium. There is no doubt that some great change is soon to overtake the theater. The drama will assume a new form, demanding a new mode of presentation, and so a new theater. Presently, I shall discuss what forms this new theater may assume, but for the moment it is enough to observe that it will be marked by a closer bond, one way or another, between the audience and the players, between the audience and the play. For a long while, the theater has shrouded itself in a sort of pseudo-mystery. Backstage has had the lure for the layman of a hat from which rabbits are drawn by a conjurer. Of course, under inspection such a hat is found to be as empty as any other, bearing even, in most cases, the mark of a respectable maker. And the inspection deepens the mystery. The stage has shunned this sort of scrutiny because our drama of today and our theater live mostly by effects, and if the effect is stripped of wonder, the theater is almost as good as dead. What a sign of weakness this is! If the snowstorm is seen to be bits of paper shaken out of a bag, and if it is found that the imitation wind is produced by the scraping of paddles on canvas, the public will lose interest in the theater. And the people of the stage, how hungrily necks are craned for a glimpse of the popular actor or of the beautiful actress should one pass in a hotel or on the street. They inhabit that mysterious, unexplored backstage, and a clever manager will encourage this sort of curiosity by advising his people not to show themselves in the street except unavoidably. The matter of seeing the actors close may be dismissed with a quip. They might be found respectable upon acquaintance, or more likely, dull. But the truth about the back of the theater is the truth about the conjurer's hat. There's nothing there to see except the pitiful little bag of tricks, the snowstorm and the wind. There is not even the maker's label. But this emptiness is not all, for as with the hat, it's quite engrossing while the rabbits are there. The worst of it is that it is so poor, so mean often, so dirty, so cramped and littered to the last dark cranny, that we wonder how the actor rabbits endure it all and keep their fur so white. A rudimentary shame on the part of the managers and a very human pride on the part of the actors have helped to keep these matters from the theater-goer. Out front there is warmth, light, comfort, elegance. The spectator is lulled into forgetfulness of work, and the play casts its spell over him. But a glimpse of the wretched barrenness of the dressing room or shop would make short work of his peace of mind, just as a knowledge of the tricks shears them of illusion. These things are becoming known because the bond between the spectator and the theater worker is already being formed. When it is full grown, such facts will not be discovered. They will no longer exist. For two movements that are bound to affect the theater of the future are bringing the lay public clamoring over the footlights and crowding in at the stage door. One, the little theater movement, is almost altogether a lay insurgency. In scores of communities it has made its way. Tradesmen, students, clerks, mechanics, people of leisure and working people with a little leisure have come together and in a short time have plumbed the silly little mysteries of backstage and have brought into their theaters a little bit of the real mystery of life and art that belongs there. And the more extensive democratic community drama movement is making play actors and theater workers of thousands who have heretofore been auditors. There will always be a professional group of artists of the theater, but in their theaters there will be a close understanding and perhaps a physical connection between the audience and the stage. In the great popular theater, it is conceivable that there will be very little distinction between the auditorium and the stage. It may be that they will be interchangeable or be one and the same. Then it is certain that the conditions of comfort and convenience that apply to the one shall apply fully to the other. that the actor shall be as well cared for in the theater as the public. Let those who are building today look to this. Visit the dressing rooms. See the workplaces of the other workers of the theater, the carpenter, electrician, property man, and wardrobe workers. Consider these workplaces not only in comparison with the front of the house, but as fit places for human beings to spend as much as an hour a day. Consider them as places where work that should have in it joy and beauty may develop. The community theaters that are going to be built within the next few years are bound to be a blessing to those who have access to them. But for the most part, their projectors and builders are laymen, knowing little of the vast work of preparation that must be done before a play is ready for an audience. Where the commercial theater builder does not care how the actor and the theater mechanic fare, the lay builder is a little likely to overlook their existence. I have seen dozens of clubs and schools with fairly adequate stages and auditoriums, but with no more than 2 small dressing rooms, one for men and one for women. I have seen several with no more than one, originally intended for a closet, but set aside as a dressing room when it was discovered that something of the sort is indispensable. Aside from the fact that the players and the workmen are human beings, quite often of the same tastes and breeding as those who occupy the front of the theater, they have a long and exacting work to perform, most of which can be done only in the theater, and their domain is the part of the theater behind the proscenium line. The actors must rehearse for several weeks before the play can be acted. They must be in the theater some time before the curtain rises on the play, and they leave it some time after the play has ended and the audience has gone home. For they must dress and make up, and should be allowed a little while to shake off John Smith and enter into Hamlet. There is, moreover, scenery to be built and painted, furniture and properties to be made, lights to be arranged, effects to be devised, costumes to be cut, fitted, and sewed. How should these activities and these workers be taken care of? First, the actors. For their rehearsals, first of all, the stage should be used. If the stage is otherwise occupied with scenery or with the rehearsals of another production, as it often is in busy theaters, there should be another place in the same building where rehearsals can be held, a room with as large a floor as that of the stage proper. But as often as possible, the stage should be used for rehearsals. Then, for their preparation to appear in a performance, their dressing and makeup. Dressing rooms must be provided, sufficient in number to accommodate the cast of the average play without crowding more than 2 people to a room. Under ideal conditions, each player will have a separate room so that he can prepare for his performance, mentally as well as physically, without disturbance. The rooms should be not less than 8 by 10 feet, should each have a window, and should be heated in winter. Against one wall, there should be a long shelf or table about 18 inches wide. Above it should be a good mirror with lights so placed that the face of an actor seated at the shelf and looking into the mirror will be well illuminated. Under the shelf, there should be a drawer in which makeup materials may be kept. Each dressing room should be provided with a washstand and with hot and cold water. There should be a high clothes closet or wardrobe in which costumes may be hung. Where this is impractical, there should be sufficient hooks to accommodate a number of costumes and means of covering them with a cloth to protect them from dust. Above the clothes hooks or at the top of the closet should be a shelf for hats, shoes, etc. It is well to provide from 8 to 12 dressing rooms, each large enough to accommodate 2 persons. In addition, there should be 2 large rooms, each with a space for about a dozen persons, these to be used for chorus, supernumeraries, or players of small parts. On each dressing room floor there should be proper toilet accommodations for each sex. Also, the ideally equipped building will have shower baths. In these days of Dunsany, Hindus and Arabs and Ethiopians may be met in many a town en route from the little theater to their homes, there to wash themselves white. It has been noted that, to preserve the unbroken wall space of the stage as far as possible, dressing rooms should not open directly upon the stage floor. In many theaters, they are ranged off galleries above the stage. On the whole, this is inadvisable. A dressing room door, inopportunely opened, will let a beam of light fall upon the stage, often spoiling the lighting of a scene. The slamming of doors, sound of voices, and other noises are almost unavoidable, and the argument usually advanced for so arranging dressing rooms that the actors can hear what is going on the stage and thus be in time for their entrances is fallacious. This very fact breeds in them a confidence that makes them careless, and they are more often late than if they were required to wait for their cues on the stage. One more thing should be provided for the actor, not indispensable, but making for fellowship and comfort, the feature known in German theaters as the Konversationszimmer, and in older English and American theaters as the green room. This should be a comfortable lounge, furnished more as a room in a home or club than in a theater, and stocked with books and periodicals relating to the theater. With the actor carefully considered in the matter of cleanliness and cheerfulness backstage, a new pleasure will come into his work. Likewise with the other workers of the theater. Closest to the actor, perhaps, the wardrobe people. In the ideal theater, 2 rooms should be set aside for the wardrobe, one for the making of clothes and another for their storage. The sewing room, needless to say, should be well lighted, should have a space partitioned off as a fitting room, should be provided with proper closets in which to hang dresses in the process of making, and should be large enough to allow for a number of seamstresses and a large cutting table. There should be a built-in closet equipped with shelves and drawers in which to store cloths, trimmings, findings, etc., for the making of costumes. For the costume storage room, a loft space that might otherwise go to waste can often be utilized. This room should have long closets fitted with bars on which dresses can be hung, and should have drawers in which other items of dress can be packed. Hats, shoes, wigs, stockings, tights, etc. These drawers should be numerous enough to allow for the sorting out of costumes by colors or periods, and should be properly labeled. Each of the mechanical departments should likewise have its 2 rooms, one a shop and the other for storage. The carpenter, if the scenery is built in the theater, often can use the space under the stage for building. If he cannot build his scenery there, either another place should be set aside or the scenery should be built outside the building. He should not use the stage. It must be kept free for rehearsals. He should have, however, a room in which to keep his tools, draw his plans, and file his ground and framing plans, bills, timesheets, etc. The matter of storage space for scenery is to be determined wholly by the amount of space at the builder's disposal and the use to which the theater is to be put. If many productions are to be made, a space should be provided for a scene dock adjacent to the stage but separate from it, unless the building is small, in which case a storehouse elsewhere may be used. Scenery should not be allowed to accumulate on the stage. The theater of the Carnegie Institute of Technology at Pittsburgh has an excellent dock shown on the ground plan. The property department needs a shop for the making of furniture, papier-mâché work, etc., and a storage room in which furniture and other stage furnishings can be stored. Often, one large room can be made to do for both. The electrical department likewise must not be overlooked. There must be closets for the keeping of incandescent bulbs, lamp dyes, plugs, connectors, cable, wire, and other electrical hardware, gelatins, color frames, etc. There must be provision in the shop for the dyeing of lamps, testing, repairing, etc. The property and electrical departments, like the carpenters, must also be fitted in a sense as offices for the keeping of electrical and property plots, full records relating to past and coming productions, bills, orders, receipts, timesheets, and like data. It may be objected at this point that these various demands presuppose a large-sized plant with elaborate equipment. As a matter of fact, they apply quite as much to the tiniest of little theaters, even more so, for in such proper ordering of space and isolation of separate activities is equivalent in getting efficiency to more ample space less carefully subdivided. For inevitably, these various kinds of work must be done in the theater, and the people who do them must find space here or there for their work, and the things they make must be kept somewhere. Unless each job and each product is assigned its proper corner, the building is soon a clutter of stuff, accumulating dust, getting jostled about and broken. Then we are back at the old dark, dirty theater we are trying so hard to improve upon. The provisions discussed above, though they are not on the stage, are very much a part of it, and go far toward making it an instrument of precision. In community buildings and schools, the various workshops, rehearsal room, etc. can often be combined with rooms serving other purposes. In any case, some provision for them is quite as important as the open stage itself. End of section 4. Section 5 of On Building a Theater by Irving Pichel. This LibriVox recording is in the public domain. The equipment of the stage. The outstanding point about the stage, apart from the life the actors bring to it, is that it is a machine. It is a mechanical device used to aid in the setting forth of a play, much as a potter's wheel aids the maker of vases, or a mortise and tenon machine helps the cabinet maker. Perhaps the cabinet maker is no less a hand craftsman because he uses the mechanical device to shorten his labor, and it is probable that the vase has a truer form for being turned on a wheel. But cabinets have been made wholly by hand, and vases turned without the potter's wheel. There are people who treasure works made wholly by hand above the machine-aided work, however artistic. The theater once did without the adventitious aids it now employs. Once it was merely a platform set in the sunlight, revealed to the sight of an assembled audience. Many believe that the theater of the future will be something of that sort, welcoming, however, in addition to or instead of the sun, the more constantly available, controllable, and subtly colorable electric light. But the Greeks had their machines for the revelation of the gods, and there is something about periaktoi, or revolving pieces of scenery. It is with the machines that the theater has concerned itself most of all. Every developed stage has employed an amount of mechanism for the producing of those effects which I mentioned in the preceding chapter, and it may be that the theater always will. One wing of the theater, the right, doubtless. Of late years, with the advent of the naturalistic or realistic type of drama, the stage has sought more and more illusion, not only in its imitations of the movements and acts of men and women, but in its representation of their surroundings. It has tried to become a more perfect machine, more nearly an instrument of precision. It may be significant to observe that, although masterpieces of drama gave impetus to the development of the illusion stage, outstandingly the plays of Ibsen, the illusion stage has brought forth no masterpieces. In this country, it may be held responsible for the buzzsaw, train wreck, or horse race type of melodrama, a type now happily removed from the theater by the moving picture with its still higher degree of visual veracity. In Germany, the stage as machine has been developed to an extraordinary degree and, for the most part, never debauched by exhibitions of effects for their own sake, as in our sensational melodrama of half a generation ago. I shall discuss a number of these German inventions in a later chapter, but for the present propose to consider the stage as a machine adapted to average demands. There are two primary demands: that the machine shall be able to do the work demanded of it efficiently and with a minimum danger of breakdown, and that the machine be subject to control. The work of the stage machine is, of course, the handling of scenery, the illusion stuff of the present-day stage. This scenery is of two types: pieces that are suspended from ropes, hanging pieces, and pieces that stand on the floor, set pieces. For exterior scenes, the first type includes drops, borders representing foliage, leg drops representing trees, pillars, arches, etc., or sections of wall, house front, or other flat architectural units large enough to warrant hanging overhead when out of use, so as to save floor space, and, for interior scenes, ceilings and back walls. The second type includes, for exterior scenes, any low-standing units such as walls, hedges, fences, tree trunks, wings, or set houses, and, for interior scenes, the side walls of a room and, very often, part or the whole of the back wall. For the manipulation of hanging scenery, the most important piece of stage machinery is the gridiron. This is a slatted platform of steel or iron joists built a few feet below the roof of the stage, just enough below to allow headroom for a man standing on it. Along the center of the gridiron, on a line at a right angle to the footlights, is set a row of blocks and sheaves of a special type, manufactured for stage use. Equidistant right and left of this center row by half the width of the stage proper, the part of the stage within the proscenium, are other rows. Over these sheaves, ropes are passed, thus hanging over the stage parallel to the back wall in sets of 3 are lines to which scenery may be attached. The other ends of the lines in each set are brought together at one side or the other of the stage, so that the 3 ropes of each set may be operated as one. On the side to which the lines are led is located the pin rail, either on a fly gallery or at the floor level. Of each set of 3, the line hanging nearest the side from which the lines are operated, the pin rail side, is known as the short line. The line most remote from it is known as the long line, and the other as the center line. On very large stages, with an opening of 40 feet or more, 4 lines to each set are advisable, not only to bear the greater weight of the larger pieces of scenery required, but also to secure a better trim or level hang of the scenery. These lines, needless to say, should be of the best hemp rope, of a weight adjusted to the size of the stage. Half-inch line is the lightest it is wise to use. This rope should be subjected to periodical inspection to forestall breaking and the falling of scenery, with consequent damage to the scenery, the play, or the actors. On some gridirons, the blocks are screwed to the underside of the grid. This is unsafe, as they have been known to tear loose. They should ride the joists, the lines dropping between each two. At least 25 sets of lines should be provided. When a set of lines is not weighted with scenery, sandbags are tied to the loose ends so that they may be lowered to the floor when needed. Frequently, a piece of scenery will be found too heavy for 1 or 2 men to raise from the floor. In such cases, counterweights in the form of large sandbags are hung on the part of the lines between the gridiron and the pin rail. The primary purpose of hanging scenery in this fashion is to be able to haul it out of sight in the upper part of the stage when it is not in use. Hence, large overhead space is necessary. This system also makes possible the use of unstiffened scenic units, such as drop curtains and borders, which literally have no legs to stand on. In large stages, the lines are controlled from a pin rail on a gallery built out from one of the side walls of the stage. In smaller stages, the pin rail may be built against one of the side walls on the floor level. This has various advantages. ease of access the foremost, and the saving of a stagehand who would otherwise have to remain on the fly gallery besides. The advantages to be claimed for the fly gallery are that its use leaves the stage floor clear of ropes, leaves the sidewall clear for the stacking of scenery, and is a valuable vantage point from which to cast light upon the stage. The stage of the Century Theater is equipped with a counterweight system that practically eliminates hand power in the raising and lowering of hanging scenery. To each set of lines is attached a metal case or container which rides up the stage wall between tracks. At the top of the stage, above each container, there is a magazine filled with buckshot. By an ingenious mechanism, when a piece of scenery hanging in the loft is to be lowered to the floor level, a quantity of the shot in the container is allowed to flow out so that the scenery outweighs the counterweight and descends. Its descent can be stopped at any point by brakes on the lines. When it is to be raised, shot from the magazine above is allowed to flow into the container until the counterweight outweighs the scenery and the scenery ascends. The shot that flows to the bottom of the chute is conveyed by an endless chain and bucket conveyor to the magazines at the top. Such a system is only warranted on stages of opera house proportions. There are also systems for controlling the lines by motors, but on the stage of average size, manpower is the safest and most dependable. Scenery that stands on the floor requires little by way of machinery. Some of it is self-supporting, as are the wings, folding screen-like pieces used to mask the sides of the stage. All set scenery is framed so that it stands rigid enough when braced from the back. Part of the equipment of every stage is a supply of stage braces for the support of such scenery. These are made of hardwood, can be extended to any desired length, have a prong at the top which hooks into a screw eye fastened to the scenery, and a foot iron at the bottom which can be fastened to the stage floor by means of a stage screw or peg. The use of these pegs demands a softwood stage floor into which they will bite easily. Good stage braces can be obtained from any reliable dealer in stage equipment. The main curtain of the theater, if it raises and lowers, is often operated from the fly gallery. It is better, however, to have it operated from the stage level, on the same side of the stage as the fly gallery or the pin rail. The draw type of curtain is always handled from the stage floor. Travelers for these curtains can be more cheaply bought than made and are kept in stock by any stage rigging firm. It is well to have the stage flooring built in lateral sections, resting on joists that run the width of the stage. When traps are needed in the floor, they can then be cut without difficulty at any point. The lighting equipment of the stage, by far the most important of its mechanical attributes, I shall describe later, but I shall treat here of one device which is structural. It is one of the German inventions for the perfection of illusion to which I have referred, and the only one I recommend to little theaters, far and wide. I recommend it because of the added beauty it can bring into the playhouse, rather than because of its merit as a part of the perfect machine. This is the Kuppelhorizont, or sky dome. The sky dome approximates in shape a quarter sphere, much like the shells commonly placed behind outdoor bandstands. The baseline begins far enough toward the front of the stage and behind the proscenium to be masked from the opposite side of the auditorium and sweeps around the back of the stage. The back and sides of the dome rise vertically for some distance and then arch at the top toward the front of the stage. The higher the dome is, the less the canopy need overhang the front of the stage, and the less it overhangs, the more gridiron space is available for hanging scenery. But it will be seen at once that the more dome there is to take the place of the usual hanging stuff, the fewer of the usual tawdry borders are needed. The late Wallace Sabine, in a series of experiments conducted with a model built at Harvard University by Theodore C. Brown and the present writer, concluded that the quarter sphere was disadvantageous to the acoustics of the stage and was not required in order to obtain the best results in lighting. He recommended a form flatter at the back and with a sharper curvature at the sides and top. 3 modifications of this device have been installed in little theaters in America. One at the Neighborhood Playhouse in New York, one at the Beechwood Theater in Scarborough, and one at the Arts and Crafts Theater in Detroit. The Neighborhood Playhouse dome is really little more than a cyclorama built in plaster. It has no canopy overhead, and the ends extend toward the front of the stage only a little distance. The one at the Beechwood Theater is similarly simplified, but even this plaster cyclorama is a great improvement over the canvas cyclorama in its stability, freedom from wrinkles, and better diffusion of light. At the Arts and Crafts Theater, the ends of the dome do not curve toward the front of the stage at all, but the top arches, forming a canopy over the back part of the stage. The only true dome in this country was installed by Samuel J. Hume at the Madison Theater in Detroit, now used as a moving picture playhouse. With such a dome, a great deal of the litter of painted scenery can be done away with. A background of light takes the place of the usual painted backdrop, and much of the scenery, usually set at the sides or hung overhead, merely to keep the eye from penetrating to the back regions of the stage, is no longer needed. Added to the stage at the time of construction, the dome costs little more than the price of its materials. The initial cost will be saved many times over in the decreased cost of scenery. The very least that should be done, if the budget does not allow for the construction of an entire dome, is to plaster the back wall of the stage. This, more than counterweights, traps, revolving stages, and all the other paraphernalia of advanced construction, will extend the possibilities of the stage machine not only for the uses of illusion, but for the service of the imagination. A familiar feature of most theaters in which productions are made is the paint bridge and paint frame at the back of the stage. Here, the scenery to be painted, mounted on the frame, is raised and lowered before the bridge. To my mind, this is a waste of space and money. Primarily, it is a waste of space at the back of the stage. If the dome is used, it is quite out of the question. But strongest argument of all, it is not needed. If the scenery must be painted in the theater, it can be painted lying flat on the floor. The saving on this item may well be enough to cover the cost of the Sky Dome. End of Section 5. Section 6 of On Building a Theater by Irving Pichel. This LibriVox recording is in the public domain. Stage Lighting, Part 1. The most vital part of the stage machine is yet to be touched upon, the only part in which any mystery is involved. After all, most of our machinery of the theater is of the simplest type, ropes and pulleys and simple bracing. In a double sense, the electrical equipment is approached with more awe. While most people know a little about the simpler laws of mechanics, electricity, guarded by an element of danger, is a matter too recondite to be brought into the fold of everyday information out of mere curiosity, or to be reasoned out as the childish working of a pulley can be figured out by common sense. It has to be studied and learned, and besides being outside common matter of fact, light is a mystery itself. Unplumbed nature, a fraction of the inscrutable life of the world, led by strings to the stage. If the little playhouse is without any mechanical convenience, if its stage is cramped and mean, it can still achieve visual beauty through light. This force brings into the playhouse the most vibrant, subtle, and affecting gift of the physical world, barring only the human presence. Ultimately, it will be seen that a forthright attempt to imitate nature on the stage can result only in failure. The painted or modeled semblances of rocks, trees, grass, or distant prospects are in the long run seen to be what they are, not what they pretend to be. Similarly, close as the light of the stage can be brought to resemble the light of the outer world, it will still be short of complete fidelity to its original. But it is, in itself, a force of beauty, an authentic transplanting of the revealer of nature's diverse beauties, so that if it fails to achieve what the manipulator tries to make it do, it may achieve something possibly more beautiful. More and more can this be true in the theater as the artist comes to regard light as a pure medium, as he learns more of its profound effect on human emotion, even on the working of the body's organs, and as he becomes familiar with the thousand subtle ways in which the earth and its atmosphere modify the light sent by the sun, reflecting and refracting it, stealing certain colors from its whiteness and leaving others, resolving it prismatically by mists and clouds and the swirls of atmosphere. These are a few of the ways in which nature plays the artist with light. They point to unlimited lessons in technique that the theater artist in light has yet to learn. The little theater, or any theater for that matter, cannot go wrong by beginning at the beginning. Let it revalue the customary machinery for stage lighting and the results achieved by its use. Later, I shall describe this customary equipment, for it has its great uses, and much of the criticism that I shall apply to it applies perhaps with greater justice to the manner in which it is used. But implicit in the system itself is a criticism of its purpose to reproduce the effects of nature under conditions that in no wise resemble those of nature, or its laying over a convention, artistic at its best, feudally anachronistic at its worst, not another convention, but a lantern of Diogenes showing up shams. Go back to the beginning. One candle rightly used, as in Robert Edmond Jones's lighting of the den scene in Redemption, is both drama and beauty. Imagine Wallace Stevens, Carlos among the candles, shown upon the stage by the candlelight of the strange room world which is the play's universe. Here is a complete wedding of drama and the mobile beauty of light itself, a light we can readily achieve. From these candles to the sun of Shakespeare's comedies, the storms of his Lear, or the mists and fogs of The Tempest is a far cry. He begged the question in extraordinary verse and acted the words and emotions of his plays in the plain light of day, which is bound to be beautiful even when it is not elusive of the moon. Right here lies the crux of the problem of installing lights in the little theater. A dual approach is required, as in any art. The creator's vision of what he wishes to do and the technician's knowledge of how to go about it. The greater responsibility rests on the first function, for we must settle whether we are to try to reproduce nature or attain a correlative beauty. To me, the beauty of a stage sunset has rarely been the beauty of a real sunset. It has been the beauty of rosy light. If anything, the unreality of the sunset has stood in the way of my appreciation of the reality of red. The beauty of red was accidental and not the artist's intention. It could not have been avoided, for it is germane to sunset, but the fact remains that the artist achieved something other than he set out to achieve. It would have been better to go in for red and attain it than to go in for sunset and attain red. If blue light imitates the moon, well and good. It is beautiful itself, and does not awaken marvel at the cleverness with which we have contrived an effect. Whereas a nicely operated moonrise or a jiggling procession of stereopticon clouds leaves us gaping while the tragedy hobbles, unattended, to its close. When the theater forsook the sunlight, it faced the question of light solely as illumination. By various means, torches and tapers, gas, limes, and electricity. It has made its art visible indoors and at night. The introduction of electric light into the theater has made possible an illumination so dependable and controllable that of late years attention has been turned to other phases of the lighting problem. Thanks must be given for most of the advance thus far to the effort of the illusion theater to imitate the light of nature. My belief is that the greater advance lies ahead in the study of light on the stage as an art medium per se. Two important things the stage worker of the modern theater contributed through his rough approximations of realistic effect, two things that will serve whatever our aim in lighting. He saw that the light at some seasons, in some weathers, and at some times of day is less bright than at others, and that it fades at dusk. He devised means, therefore, of varying its intensity. Second, he perceived that at sunset light is one color, at noon another, and by full moon another. He gave us dyes and color screens, and with them and his dimmers brought to the stage the important element of control. Other advances through other agencies in the theater tend to subtleize the function of light, carrying it beyond primary illumination. Second, perhaps, comes the scene designer, who demands that the light, in addition to illuminating the players and stating the time of day or year, shall contribute values to his design as picture. It shall be made to cast shadows where dark masses are wanted in his composition. It shall highlight other features of the scene. It shall reinforce the painter's work with color. It shall give plasticity to the builder's work with its highlight and shadow. Next, the dramatist and producer make their demands. The light shall reinforce the mood and meanings of the play. By its intensity or dimness, it gives atmosphere. By its color, it has a direct psychological and physiological effect on the spectator, sensitizing him to values in the play he might not perceive were it enacted in light of another sort. Dramatist, director, and designer, in the lighting of a play, if nowhere else, should be so much at one that it is easy to understand Gordon Craig's wish that one man should combine the functions of all three. Light in the theater, then, 1. Illuminates the stage and actors. 2. States hour, season, and weather through suggestion of the light effects in nature. 3. Helps paint the scene, stage picture, by manipulation of masses of light and shadow and by heightening color values. 4. Lends relief to the actors and to the plastic elements of the scene. And 5, helps act the play by symbolizing its meanings and reinforcing its psychology. To achieve these 5 functions of stage light, 5 different kinds or sources of light are not, of course, needed. One light may combine several or all of these functions. In Joseph Urban's lighting and setting of the last act of Tristan and Isolde some years ago at the Boston Opera House, a beam of late afternoon sunlight struck across the stage to the figure of Tristan lying beneath a great oak tree. Slowly, as the day waned, the sun patch crept from the figure until, at his death, it had left him in cool shadow. Thus, a light that illuminated, that told the time of day, that gave the figure of the singer and the bole of the great tree high relief by striking from only one side, also aided symbolically and psychologically in the interpretation of the drama. Thus, to make light function in many ways is to use it with a sense of its ductility and subtlety as a medium of theater art. In it, we have the only single agency in the theater that can work with all the other agencies, binding them together, that can reveal with the dramatist, paint with the designer, and act with the actors. The machinery by which this medium is brought to the stage and through which its wonders are wrought commands a deep respect. Tradition has already laid its heavy hand here, and innovation in lighting equipment moves slowly. It is almost wholly within the last 5 years in the United States that lighting units of marked novelty have been introduced. Of first importance is the machinery of control, the switchboard and dimmers. The customary place for the board in American theaters is at one side of the proscenium arch, either on the stage floor level or on a perch raised some 9 or 10 feet above the stage floor. The manifest disadvantage of this location is that the operator cannot see the whole of the stage and must depend for his cues upon a stage manager. It has therefore become the practice in many European theaters to place the operator in a pit directly in front of the stage, shielded from the auditorium and facing the actors. From here, he can watch the action and see the effects of his lights constantly. Telephone connections with lamp operators at the back of the stage enable him to keep them under his control. The construction of the board and mounting of the switches are strictly prescribed by boards of fire underwriters in various cities, and need not be detailed here. The important consideration at this point is that, so far as possible, each light unit on the stage shall be subject to central control from a vantage point from which the stage can be seen, that each unit shall be subject to separate control, that groups of like units classed by location or color shall be subject to group control apart from other groups, and that the stage light as a whole shall be controllable apart from the house lights. That is, assuming, for purposes of illustration, the arrangement of lights common to most theaters. The white lights of the first border shall be controlled by a switch apart from that controlling the white lights of the second border, or the third, or the fourth. So, likewise, for each color circuit of each border separately. Then, there should be a white border main switch controlling the white lights of all the borders and a blue border main, etc. Above these, there should be a border main switch controlling all the border lights simultaneously, and thus with each division of the stage lights. Overall, one stage main switch should control all the lights of the stage. The auditorium lights, with their own switches, should be controlled from the same board as the stage lights. The outstanding item of expense in building a good switchboard is the cost of dimmers, the resistance devices by which the intensity of the light is controlled. They vary in capacity with their wattage and type, but the dimmers, more than any other part of the control system, contribute to the flexibility of the machine. In a modern theater, they are indispensable. So far as possible, there should be a dimmer for each switch on the board, controlling each light unit separately. With master levers, related light units can be ganged and controlled simultaneously. When only a limited number of dimmers can be afforded, it is possible so to construct the switchboard that circuits to be dimmed can be shunted through the dimmers, while circuits that need not be dimmed remain on constant. A very ingenious board of this type was designed by Mr. Bassett Jones for the Artists Guild Theater in St. Louis. This board has 8 dimmers, which can be used for any 8 light units on the stage, giving it a far greater flexibility than it would have if only a particular 8 could be dimmed. It is, however, rather complicated with its dual system of constant and dimmer plugs and connectors, so that only great familiarity with it makes it quick in action. In addition to the switchboard type of dimmer, there are also smaller dimmers made for use with nitrogen lamp spots and floods. Where these are used, I believe they should be set by the main switchboard rather than on the lamp itself. Attached to the lamp, they require an additional operator and break up the centralization of control. The actual stage lights fall into two classes: stationary and movable. The stationary or fixed equipment has remained, on the whole, highly conventional. It consists primarily of the footlights, a trough of lights set along the floor at the front edge of the stage, throwing light upward upon the actors and the scene, and the border lights, hanging troughs, adjustable in height, throwing their light downward. The first of these border lights, often known as the concert border, hangs immediately behind the curtain or proscenium drapery, and the others are hung at intervals of 7 feet from center to center. The footlights and borders are usually wired in 3 circuits, each circuit being filled with lamps of a different color, customarily white, red or amber, and blue. Of late, these customary units have been put on trial and found wanting. They serve principally and almost exclusively the first function of stage light, illumination, and are found on the modern stage not to serve it well. Footlights especially have come under the ban, though the campaign against them has been waged a little indiscriminately. When footlights alone are used in a realistic scene, they are bad. If the light from the floor dominates, the undersurfaces of the face, chin, nose tip, eyelids are unnaturally and disagreeably accentuated. If the light from below and above is balanced, the result, though more natural, is perhaps as bad, for the lighting is flat, and there is no relief in the features or figures of the players. For plays and scenes of a heroic or fantastic sort, treated decoratively rather than literally, lighting entirely from above gives interesting and picturesque results. It shadows the features heavily and lends a sculptured, massive quality to the face. More and more, this overhead lighting has come to be used, and with some producers has been made a fetish. The very quality that makes this sort of lighting interesting in scenes of a certain kind exhibits its strongest disadvantage in naturalistic lighting. In the average room, during the daytime, light pours in through windows, striking faces at face level. The light comes mostly from one side of the room, or if there are windows on more than one side and the light comes in several directions, it comes in varying degrees. The sun does not shine in 2 directions at once. That is to say, though light may come from more than one direction and be reflected multitudinously by walls and ceiling and, in less degree, the floor, the balance of intensity is always in favor of one direction, and this direction is not up or down, but in a line approaching a right angle to the erect figure. End of section 6. Section 7 of On Building a Theater by Irving Pichel. This LibriVox recording is in the public domain. Stage lighting. Part 2. Something of the same sort is usually true out of doors. Only at noon do we have literally overhead lighting. Even then, the beam of light is so broad as to envelop the figure on all sides, and is so variously reflected by the dome of the sky, by trees, rocks, water, houses, that there is, in addition to the direct downward light, a considerable, general, diffused illumination. At most hours of the day, the rays of the sun fall upon the earth and its people at a long angle. The factor that gives relief and prevents a dull flatness in the light of nature is the dominance of east over west in the morning and of west over east in the afternoon. Night illumination indoors, though usually from fixtures above head level, is reflected by all the walls of the room and by all the objects in it. A soft, diffused face-level lighting is thus warranted in almost all circumstances. The hard glare of foots and borders used unrestrictedly does not supply this need most happily. Used moderately, footlights have a distinct function, until better means of moderating the crude shadows cast from above shall have been devised. An effort to throw light upon the stage at an angle less perpendicular than that of the footlight and border has been made at the Little Theater in New York. Here, certain sections of the ceiling paneling can be lowered and light thrown upon the stage by diffused spot lamps at an angle of 45 degrees. In Mr. Belasco's theater, lights have been installed in the face of the balcony, achieving the same result even more satisfactorily. I believe that, in good time, beautifully designed lighting units will be frankly set or hung in the auditorium of the theater. The footlight equipment of most theaters is, as it has long been, unmodified, consisting merely of rows of incandescent lamps of low standard, usually 40 watts. The border lights have seen more innovation during the past few years, especially the first or concert border, most used in lighting interior scenes. Originally, these border lights were intended to light not only the stage, but also the hanging strips of canvas, known as borders, formerly used to suggest a ceiling in interior scenes, and still used to represent foliage and to misrepresent the blue sky in exterior scenes. With the use of flat ceilings for interiors comes a demand for a light that illuminates the scene rather than the ceiling. This is best supplied by the X-ray border, made up of a smaller number of lamps than the old border, but of higher standard, each lamp being 150 or 250 watts. Each lamp is set in a separate compartment, separated from its neighbor, and each lamp is backed by an X-ray reflector of mirrored glass with whorled corrugations, diffusing the light evenly over a large area. Each compartment may be fitted with a color screen of gelatin or dyed glass. Often 2 spot lamps, large and small, are mounted on this border to accentuate the light on certain areas of the stage. The other borders, used mostly for exterior scenes, must serve to flood stage and scene with light. The old type of border does not serve adequately, even in the type of scene for which it was designed. The use of sky borders has largely given way to the high cyclorama of canvas or plaster, leaving the sky prospect open to the eye as far as the sight line reaches. The overhead lighting must be powerful enough to flood stage and sky with light. It is becoming more and more common to reinforce the ordinary border light equipment with hanging 1,000-watt lamps in specially constructed steel hoods. In the Arts and Crafts Theater in Detroit, Sam Hume installed his entire overhead equipment of such hanging lamps and did away with the old border light altogether. In the average theater, however, these lamps are more in the nature of movable lamps than of permanent equipment, and will be further spoken of below. The footlights and border lights and occasionally vertical strips inside the proscenium frame at the sides constitute the whole of the stage lighting equipment that is more or less a part of the structure. They go with the building. Everything else is movable and falls into the second classification of lighting units. But in the structure of the stage, provision must be made for the use of such additional lights. Outlets in the form of stage pockets are set at regular intervals in the stage floor. Into these pockets, spot and flood lamps may be plugged. The pockets are set in the stage floor in 2 lines running up and down stage, a short distance behind the proscenium opening at either side of it. There are usually from 4 to 6 such pockets on each side of the stage. Sometimes there is one at the back of the stage and one or more in the fly gallery. Occasionally, also, in houses served by alternating current, there are pockets served by a small house generator supplying direct current for the use of arc lamps. In some theaters, also, there are pockets connected with storage batteries intended to supply an emergency service or for use with lighting units of a voltage other than the usual 110 volts. The pockets must, of course, be carefully insulated and covered with a hinged iron lid set flush with the floor. The movable lights are of two general types: floodlights for general diffused illumination and lens lights for concentrated direct spotting. Under the first heading may be classed all special lights known in stage parlance as strips, floods, or bunches. Strips are small troughs fitted with from 3 to 10 sockets and are used in lighting offstage backings, set pieces of scenery, and small areas where a special accent of color or intensity is wanted. Bunches, now largely obsolete, are hoods set on extension standards, fitted with 10 or 12 sockets each. These have been replaced by flood lamps burning 500 and 1,000 watt nitrogen-filled Mazda bulbs. The hoods of these flood lamps have diverging sides or are fitted with a reflector behind the light and have grooves at the front of the hood for carrying color frames. Formerly, such lamps were equipped with arc lights, but the nitrogen lamp has wholly displaced the arc in flood lighting. Its advantages are that it does not require an attendant to feed the light, that it can be dimmed, giving it range of intensity to make up for decreased brilliance, and that it can be burned on either direct or alternating current without the annoying buzz of an arc light burning alternating current. Spot lamps are mounted in closed iron hoods, emitting light from only one end through a lens. The hoods, like those of flood lamps, are set on extension standards and can be tipped up or down and turned from side to side. Arc spots are still in general use, as the 1,000-watt lamp is not sufficiently brilliant for use on large stages or for long throws. In little theaters, however, the 1,000-watt spot is bright enough and has all the advantages over the arc that apply to the newer type of flood lamp. For such small stages, the principal consideration always should be centralized control, and it cannot be got with the arc light. As incandescent gas-filled bulbs of still higher standard are developed, the arc spot will cease to be used, even in large theaters. There is also a small variant of the spotlight known as a baby spotlight, burning a lamp of 150 or 250 watts. Used with care, this is one of the most valuable stage lights we have for producing delicate variations in light volume and color in particular areas of the stage. These small lights may also be dimmed. I have referred above to hanging hoods with 1,000-watt lamps for general illumination. Where these are not made a part of the permanent lighting equipment of the theater, they may be introduced for special scenes and effects, being hung where desired, and massed in such numbers and of such colors as needed. The hoods are equipped with chains by which they may be hung upon pipe battens and tipped as desired. They are plugged, like other movable lights, into floor pockets or fly gallery pockets. The color of light on the stage is obtained in 3 ways. Where lamps of low standard, 25 or 40 watts, are used, as in the foots or borders, they may be coated with dyes, put up for the purpose, made with a collodion base. The burning lamp is dipped into the liquid and left alight until the dye coat has thoroughly dried and hardened. Bulbs of high standard, however, cannot be dyed, as the dye does not stand up under the intense heat generated by a lamp of 100 or more watts. As a matter of fact, few of the commercial dyes are wholly satisfactory, even with smaller bulbs. The blues especially deteriorate under heat, either fading or cracking or burning to a purple or black. The rays of larger lamps, burned either in flood or spotlight hoods, are colored with gelatin mediums held before the light in frames of proper size. The gelatin colors also fade under heat and, being very fragile, crack and tear and must be frequently renewed. For durability, the best color medium is a sheet of glass with the color blown in. Unfortunately, such glass is very costly, cannot be had in a large range of colors, and is usually not as translucent as might be wished. Mr. Monroe Pavere of Boston has made interesting experiments with mediums of dyed glass. He manufactures his own dyes and claims for them a much longer life than the commercial variety enjoys. His mediums are highly translucent and are, of course, far more durable than the gelatin mediums. He makes them, however, in only the 3 primary colors, for his development of color screens has been ancillary to experiments of a larger intent, the development of a synthetic lighting system. The principle of his color system is simply the principle of the prism inverted. The prism breaks white light up into its primaries. Mr. Pavere unites the primaries to make white. By combining his red, green, and blue light in varying degrees of each, he is able to obtain any color in the spectrum. To pale out his lights to tints, he includes in his border and footlight equipment a 4th circuit of white lights. To my knowledge, only one theater has been equipped by Mr. Pavere, the Toy Theater of Boston, now the Copley. But in the short-lived tenancy of the house by the Toy Theater Company, there was never a wholehearted effort to test Mr. Pavere's equipment. Experiments with synthetic lighting have been conducted at various times and places by Sam Hume, Norman Geddes, the present writer, and others. The results more than reward the effort of such experiment, and I commend a study of its possibilities to all workers in little theaters. In addition to the typical theatrical lighting units, other units not designed primarily for theatrical use are being adopted. Foremost among these are the reflectors of the X-ray type. These are made in a number of sizes and shapes, but are of 2 types, the world reflector and the parabolic reflector. The first type gives a diffused light and the second a concentrated beam. The X-ray flood lamps, manufactured for lighting the exteriors of buildings and for illuminating night construction jobs, are coming to be used on the stage. They can be focused, have a higher efficiency than a lens light burning the same number of watts, and produce a more pleasant spot than the sharply defined light area of the conventional spotlight, projecting a brilliant ray, most intense at the center and fading toward the edges of the field. There are a number of firms manufacturing lights of this type, and they are now generally used for lighting outdoor pageants. They are quite as valuable in the indoor theater as on the pageant field. I have used frequently, instead of baby spots of the regular type, automobile windshield spots, burning a 6-volt lamp. These cost perhaps 1/10 as much as the regular type, and can be used on a special circuit supplied with current either through a small step-down transformer or from a storage battery, kept continually charged by running current into it from a strip of carbon lights wired in series multiple. These windshield spots are usually equipped with a swivel and trunnion mounting so that they can be turned in any direction, are focusable, and have a clamp by which they can be fastened to pieces of scenery or upright pipe standards in the proscenium entrance. Besides a goodly number of well-distributed stage pockets into which movable lamps may be plugged, there should be points of vantage from which lights may be cast, perches and bridges elevated above the level of the stage. Most useful is a bridge across the stage just inside and above the proscenium. From this bridge, special flood and spot lamps may be manipulated. Often perches are built out from the wall at either side of the proscenium, from which spots may be thrown down to the stage. Occasionally, these are movable structures with several levels and can be wheeled to various points off stage. The fly gallery also is used for spotlighting. When a false proscenium is used, the overhead bridge and side perches are sometimes built into the structure. In planning the lighting equipment for a small stage, all thought of the usual theater installation can be set aside. Border lights of the old type are not useful enough to warrant the expenditure of the money they cost. Footlights, too, though useful when no better means of front lighting can be devised, can well be replaced by face-level lights from the auditorium, concealed by wall traps or by the balcony rail, or hidden in decorative coverings suspended, chandelier-like, from the ceiling. The essentials for a flexible, adaptable lighting system are centralization and delicacy of control, numerous and well-situated current outlets, and as wide a variety as possible of movable lamps for flooding and spotting. There should be enough circuits to allow the use of a 3 or 4 color system along the lines of the synthetic system of Mr. Pavir described above. Along with this, there must be facilities for throwing light from above the stage from bridges and movable platforms. The only permanently installed piece of lighting equipment that is absolutely necessary is the X-ray border at the front of the stage for the lighting of interior scenes. With a carefully planned switchboard and dimmer bank and numerous pockets or current outlets for the initial equipment, there is hardly any limit to the development of the little theater's lighting facilities, for if it must begin with only a few lighting units, it can acquire more from time to time, and with each acquisition build up its means of achieving beauty. And in this direction, the most vital contributions to the craft of the theater are yet to be made. End of section 7. Section 8 of On Building a Theater by Irving Pichel. This LibriVox recording is in the public domain. Stage machinery and its settings. I have made mention earlier of the ingenuity so often demanded of the little theater stage director. The limitations of his stage often compel him to an inventiveness different only in scale from that displayed by the great German technicians of the theater. No Harvard student who ever shifted scenery for the dramatic club in Brattle Hall can outgrow his enthusiasm for the feats achieved on that absurd stage. At the Artist Guild in St. Louis, it gave us unbounded glee to set the massive chamber of the Queen's enemies on the cramped stage there. To be confronted with deficiencies of one sort or another, mechanical or fiscal, which must be overcome, is unquestionably a spur to ambition. To struggle with material barriers, space, time, physical means, and accomplish results in spite of them, to wring beauty out of meager cheesecloth and tinsel when there is no money for silk and gold galloon, is a victory of sorts, and without the fighting and winning of such battles as these, half our little theaters might never have been, and much of their best work might not have been done. Practically all modern stage machinery has been devised to heighten effects of nature, and therein it differs from the machinery of the theaters of the greatest eras, which was devised to produce effects beyond nature. The Greeks and Elizabethans left nature strictly to herself, but had a fairly elaborate mechanical system by which they exhibited gods, demons, ghosts, and visions. One of the first mechanical improvements of our present-day stage was the Drehbrunne, or revolving stage, invented by Herr Lautenschlager. Its purpose is to move, without inordinate intermissions between acts, scenery far heavier than men can handle. The cult for realism demanded a greater plasticity in scenery and consequent increase in mass and structural complexity. The revolving stage is a great turntable on which as many as 6 or 7 scenes can be set at one time and revealed successively to an audience by revolving the table. The scenery for the entire play is set up on the day of the performance, and no shifting of scenes need be done during the progress of the play. The designing of scenery to fit the revolving stage, developed to its highest point by Reinhardt, is so little understood in this country that our few revolving stages are seldom used. The Century Theater stage in New York has a turntable, but I do not know of any instance in which the scenery for an entire performance was set upon it. Mr. Winthrop Ames had a revolving stage installed in his little theater in New York, but as this stage is only 35 feet in diameter, he found it inadequate for the setting of many of the scenes. Mr. Harry Bishop, in building the Liberty and Fulton theaters in Oakland, California, constructed revolving stages of adequate size, but evaded the problem of devising scenery especially for them by installing a revolving gridiron also, so that the old-fashioned sky and foliage borders could ride around the stage with the set to which they belong. A little labor is saved in shifting scenes during performances, but I doubt whether the saving equalizes the cost of installation of these expensive devices. A device of similar intent is the sliding stage, a great wagon the size of the stage opening, or rather 2 or 3 of them, run as desired before the proscenium opening and capable of being pushed off after being used into houses at either side of the stage or lowered to the basement, there to be reset for another scene. This device avoids some of the limitations of the revolving stage, in that scenes need not be made to articulate closely as they must in order to fit the circular bounds of the turntable, but it is tremendously costly and requires a great stage space. There are other devices of like intent, such as the Asphalia stage, built in transverse sections that can be raised and lowered on hydraulic plungers, and Steel Mackay's elevator stage installed in the old Madison Square Theater, New York. None of these devices can serve either the little theater movement or the art of the theater. They are deadening and divert effort from the true end of all experiment and advance in the theater. There is no doubt in my mind that the sort of theater that wants to be built is one in which the machinery is reduced to a minimum, efficient, controllable, but never controlling the sort of work that must be done on the stage. In order to have a modern, well-equipped stage, none of these innovations is needed. Of far more purpose for the modern theater are certain tendencies now manifest that appear at first glance like reversions to an older type of stage. I refer chiefly to such a stage as that built by Monsieur Jacques Coupeau for his Théâtre de Vieux Colombie, which for 2 seasons was a strange intruder among the more literal stages of New York. Indeed, save for the use Monsieur Coupeau made of modern mechanical flexibility, his stage was a first cousin to the Elizabethan stage, though his arrival at its particular form was not a case of atavism, but a philosophic realization of the true limitations of the theater. His stage consisted of 3 parts, a forestage, reached from the rear stage or from the main floor of the auditorium by steps upward, or from doors high in the walls flanking the proscenium, whence steps led down to the stage level. Second, the stage proper, and third, an upper stage or balcony engirdling the main stage. This balcony and the space below it might be variously shut off from the main portion of the stage by tapestries, lattices, screens, or sections of scenery, flat or pierced with windows or doors. Steps could be variously placed to give access to the balcony. Thus, without the use of strictly representative scenery, Coupeau had a stage which provided every facility for the presentation of a play, entrances, exits, and elevations. It gave scope to the necessities of action and the agility of the actor. Such a construction may be said to be as much scenic reform as reform in mechanics, except that it largely renders the latter unnecessary. I should not deem it part of the purpose of this paper to mention scenic matters at all, were it not that very often a certain amount of scenery, like a certain amount of lighting equipment, goes with the building. The contract for the building and its rigging often specifies also a garden, plain chamber number 1, and fancy parlor number 3. Or the like. Whether they are thrown in or not without extra charge, they should be courteously but firmly refused. They stunt the timid imagination and somehow, perhaps because they are real scenery, never get thrown away. For the scenic equipment of the stage, I can do nothing better than refer the reader to the permanent setting devised by Sam Hume for the Detroit Arts and Crafts Theater, of which he was for 2 seasons the director. This setting consists of a certain number of interchangeable units, flats, door pieces, window pieces, arches, and pylons. Its initial cost is low, far lower than that of several sets out of the scene painter's catalog, and its usefulness infinitely greater. In addition to this, it has beauty. It may be that the stage of the future is to be something quite different than that we now have. As a theater of truth supplants the theater of illusion, it may be found that the stage of today does not answer at all. The theater is undoubtedly in a transitional period, and artists are striving for new forms and new methods of presentation. What directions these tendencies may take, it is not the purpose of this paper to forecast, nor would it do to advise the adoption of a type of stage not yet tested or of widespread use. Where there is an experimental and creative attitude toward the theater, such types will be evolved without any such rudimentary manual as this. Where a manual is wanted, a stage should be built that can be used easily by everybody who wishes to use it, and which will give readily, in return for effort spent upon it, a revenue of beauty. These pages will achieve enough if they go a little way toward eliminating the usual inept, difficult constructions that for these many years have cumbered the way of folks, young and old, who wish to entertain themselves in the theater. More and more, they seek such entertainment at their own hands. More and more, their efforts are being fostered by educational bodies and organizations allied with the theater. Such aid as this pamphlet may bring them is hopefully dedicated to their service. End of Section 8. End of On Building a Theater by Irving Pichel.